experiment.
Hey guys, I'm Brett, and I'll be talking about the bomb calorimeter. Now I know this will be the 6th time you've seen a similar presentation, so I'm going to try to make it a little interesting. So first we're going to look at obviously the goals of the experiment, which would be to understand a bomb calorimeter. And this is important because this is a very common piece of equipment in the food industry. You also want to determine the thermal capacitance of the calorimeter so you can, it's almost like setting it up so you understand how many calories are in the actual food. And finally, we want to determine the heat of combustion of the samples provided. That's how you find how many calories are contained in that said food. Now the concept we use, this is a basic equation here. We're going to use this version as well as just in a little bit edited to where it'd be Q over T equals your CV. This is known, so you solve for CV as well as solving for anything in this equation so you have all your aspects. So why? This is the big reason here for me, the motivator. I was going to talk about the whole, when you're looking nutrition, when you're looking at calories in, calories out, different things, but we already had 2 great presentations on that, so I'm going to speed that up just a little bit. Basically, if you haven't heard, it's the very basic idea is if you eat more calories than you work off, then you're going to gain weight, and vice versa, to lose weight. Like we learned earlier, there's a lot of different things that affect that whole rate there, but that's the basic idea. So the bomb calorimeter will tell you the heat energy and your sample, which in one of these cases is going to be candy. And from there you can determine their calories or kilocalories, and that will give you a basic idea of the nutrition of the food. That's why learning how to use a bomb calorimeter is so important, because it is used in the industry very often. So the setup is very basic here. The bomb is actually in the center here. The sample will be placed in the bomb. The bomb will be pressurized with pure oxygen. To do that, we will purge it. And then from there, you will have an ignition wire touching the food. The bomb and the ignition wire will be submerged in water with a stir to keep the water at a constant temperature. And there's a thermocouple connected to a computer to actually read the data from there. So let's go into the procedure. So the first thing you do is you set up the bomb itself. So that's where you place the sample inside the pressurized container. From there, you measure out a set wire of nichrome ignition wire. You want a set distance so you have control all your variables that would change the heat. From there, you connect the wire to the food. Make sure it is enclosed in the bomb. You'll connect a oxygen tank to the bomb to pressurize the bomb. Then you want to release that pressure and then pressurize it again, release it one more time, and finally repressure it. That purges the bomb of all the regular air and just make sure it's pure oxygen in the sample. From there, from there you want to prep the water jacket, which is basically putting the water in the outside container. And then you want to make sure your instrument is connected to a computer. From there you put the bomb inside the water jacket and seal that all up to begin the actual experiment. From there you will ignite the food, will determine the delta T based on the thermocouple connected to the computer. You want to wait till that evens out, but you don't want it to temperature to start dropping. And then after you do that with our test sample, and then after that we will use a piece of food to determine the calories in the food. From there, you will shut down everything, make sure everything is depressurized. This doesn't seem like it'd be that dangerous, but it can be very dangerous because you're dealing with a pressurized container and it's fire. So it can be very dangerous if you're not careful. So this is just some basic calculations and predicted results. Obviously, we'll be using, you want to find the MCV of the actual bomb itself, because the heat will be going through the bomb into the water, which is actually temperature is actually being read. And then we want to use the benzoic acid, which is our control sample, and you find the delta T with that, and from there, that's how you know when you use your actual candy sample, how you can figure out the heat from that. And that's all I got, so if you have any questions, let me know. Oh, I need to add one resource to here. I need to add Jessica and Daniel's presentation. So I didn't have to explain all that. Thanks, y'all.